Hey families, based on the order that you watch this video, you might watch this after the first one, and I'm going to explain what all of these things mean because I just assumed that the students were watching it and not the parents. I apologize. So this top left box and this graphic organizer, this giant plus symbol with question mark, LCM, box with an R, work, and answer. All of that put together is called the problem solving matrix. It's a basically a graphic organizer. It's late and getting tongue tied here. It's a way for the students to just kind of organize their thinking, organize their math brain on paper, if you will. And it's been proven successful with the students adding and subtracting fractions and mixed numbers. So I really encourage them to practice using this before they try to move on to algorithms without this. But nevertheless, let's jump right into it. This question comes from the page that the PDF document that's on this Google Classroom lesson, and it's question number 16. It's 7/8 take away 2/3. Um, First, I asked the students to look at these denominators 8 and 3 and ask if they're the same number. They are not, obviously. And in that case, we come over here to the LCM box and we stack 8 and 3, the denominators, and we ask if they're related. Related means that while skip counting 3, I say 8. Let's see if I do that. 3, 6, 9, 12. I don't say 8. So therefore, I'm going to put an X there. They're not related. In the other example, the denominators are related. There's 18ths and ninths, and 18 is a multiple of 9. 8 is not a multiple of 3. So when that's the case, I have the students list out 5 or more multiples, basically list out their multiples here until they find one that's the same. So let's just jump into it. 3, 6, 9, 12, 15, we'll go 18, and then let's come up here and go 8, 16, 24, and as I can see here, 24 is bigger than 18, so I need to jump back down here. 3, 6, 9, 12, 15, 18, 21, and you guessed it, 24. So after the students find a number that's the same, a common denominator, I have them box them in or circle them in, and that lets the students see, okay, these two factors, these two numbers here, 8 and 3, they have 24, which is the smallest number that they share. Basically, their least common multiple or their common denominator. So I'm going to rename these fractions right here with a denominator of 24. And remember, it's subtraction, so we put our sign here. And I need to ask the question, how did this 3 become a 24? Well, if I look, 1, 2, 3, 4, 5, 6, 7, 8, the 8th multiple, or 8 times 3, gave me 24. If I change the denominator, I have to change the numerator by the same thing, so they're equivalent. And before they do anything, before they multiply here, I have the student ask the same questions about this fraction. So nothing's forgotten and no steps are skipped. How did an 8 become a 24? Well, 1, 2, 3. The third multiple times 3 down here gave them 24. And if I change the denominator, I come up here and change the numerator. So now let's rename these fractions based off of their common denominator. 3 times 8 is 24, 2 times 8 is 16. Over here, 3 times 8 is 24, and 3 times 7 is 21. So the students now have the task of finding the difference. Sorry about that. I don't know what happened. I think there's like a little zerp in the video at this point. Something happened and my thing stopped recording. But anyways, uh, we are right to the part of the problem where we're saying, okay, what is the difference of 21 and 16? Um, Students at this point can stack 21 and 16 like a standard subtraction problem. They can do that and then regroup and go that route if they want to, or they can just go 16 to 20. Well, that's 4, and then one more would be 5. Or they can count up 16, 17, 18, 19, 20, 21. The difference between 21 and 16 24ths is 5 24th. Um, the reason I highlight what I was saying there and just the strategies of using your fingers and what have you is I want the students to be comfortable using their math strategies and understanding that they're developing their math skill set. They don't need to compare it to anyone else's. If they're still using their fingers, to count up or find differences, or they want to slow down in a moment, I'm fine with that because mathematicians are precise. I tell that to the kids all the time. We work on being as precise as possible, and if that means slowing down, then slow down. But anyways, hopefully this helped with adding and subtracting common fractions. And comment, email, let me know if you guys would like to see any other questions worked out from this PDF or any other help that you may need. Thank you all.